Hello my friends and welcome back to the You Can Do TV channel. The process of hardwood lumber production involves several key steps that contribute to the overall efficiency and quality of a sawmill. While each sawmill business may have its own unique characteristics, such as size, configuration, and production output, the general process remains similar. Let's explore the steps involved in producing hardwood lumber. Log supply. One of the significant challenges for sawmills is the availability of logs. Mills often rely on their own timber buyers who work full-time to procure logs from various sources, including producers and their logging crews. Log trucks transport the logs to the mill, where they are unloaded, sorted, measured, and inventoried. The mill may need to reach out to distant locations, sometimes up to 150 to 200 miles away, to secure an adequate log supply. Log yard. Upon arrival, the logs are evaluated for species, diameter, defects, straightness, and heart content. The log yard manager enters this information into the inventory system and organizes the logs in designated areas based on species and quality. The mill manager closely monitors the age and condition of the log inventory and makes cutting decisions accordingly. In hot weather, lower log inventories are preferred as logs can degrade quickly, while the fall and winter act as natural refrigeration for longer log storage. Debarking. The first step in the manufacturing process is the removal of bark from the logs using a debarking station. This process eliminates dirt and grit that may be present in the bark. Subsequently, the logs pass through a metal detector, ensuring that any logs containing metal are identified and the metal is removed to prevent damage to the saw blades in the mill. The bark that is removed during debarking is ground and sold for landscaping material. Saw filing. The saw filing department is crucial for maintaining the performance, yield, and appearance of the final product. Saw filers are responsible for the maintenance and upkeep of the saw blades throughout the mill. Their expertise is vital in ensuring the smooth operation of the sawmill, and their experience contributes to the mill's overall efficiency. Sawing. The logs are then conveyed to the head saw deck, where they are positioned on a carriage. Advanced technology is used to scan each log for its size and shape. Linear positioners adjust the log precisely on the carriage for the head sawyer. The head sawyer begins cutting boards from all four sides of the log, gradually reducing it to a manageable size for further processing. Slab cuts and jacket boards, which have no lumber value, are removed from the outside of the log to create a square, four-faced cant. The slab cuts are sent to the chipper, while the jacket boards are sent to the edger. Resawing. The squared log or cant is conveyed to the resaw, where it is processed further. Waste material generated during the sawing process is conveyed to a grinder, where it is converted into various products, such as chips for energy plants or core material for fiberboard. The resaw allows for increased production and grade recovery. The sawyers at the resaw have more time to make decisions about which face of the log to choose, resulting in higher yields and increased returns. Edging and trimming. At the edger, the operator makes decisions regarding the removal or retention of wane, bark or lack of wood, on the boards to maximize mill yield. Modern mills often have optimizing edgers that automate some of these decisions. The boards then pass through a double-end trimmer, where each end is inspected, and the operator can choose to trim the boards for improved appearance or grade. Industry standards typically trim boards 2 inches over the nominal length. Grading and quality control. The graded boards proceed to the grading station, where the grader or lumber inspector inputs information such as board footage, thickness, grade, and final trimming decisions. The grader ensures that the mill's production meets industry standards, such as those set by the National Hardwood Lumber Association, NHLA, while also meeting customer specifications. The grader plays a critical role in maintaining grade consistency and maximizing mill profits. Any quality issues identified by the grader are quickly communicated to the mill manager for necessary adjustments. Sorting and packaging. The boards are then sorted on the green chain by lumber handlers based on their grade, thickness, and length. Experienced handlers play a vital role in detecting quality issues and ensuring the proper sorting of lumber. The sorted boards are double-banded, labeled, and organized into packages according to species, grade, and thickness. These packages are then sent to the shipping area, where they are loaded onto trucks for delivery to customers. Maintenance and quality assurance. A well-maintained sawmill is crucial for producing high-quality lumber consistently. The maintenance department is responsible for keeping the production running smoothly and ensuring that the equipment is in top shape. Modern equipment and technology, combined with a focused and well-trained team, contribute to the overall success and competitiveness of the mill. Maintenance and quality assurance. A well-maintained sawmill is crucial for producing high-quality lumber consistently. The maintenance department is responsible for keeping the production running smoothly and ensuring that the equipment is in top shape. Modern equipment and technology, combined with a focused and well-trained team, contribute to the overall success and competitiveness of the mill.
The chair manufacturing process at Karloman, located in Izmir, exemplifies excellence in craftsmanship, technology, and quality standards. The first step in the chair production process is the selection of premium quality wood. Only the finest solid wood materials are used, selected not only for their strength and durability, but also for their visual appeal and sustainability. After quality checks, the wood is sliced into thin layers that will later be molded into plywood. This multi-layered wood is then dried to achieve the ideal moisture content, ensuring stability and preventing future warping. The drying process is carefully monitored to create a foundation that can withstand demanding shaping and molding techniques. Molding process with shaped plywood. Karloman specializes in molded plywood, a process that combines artistry and precision engineering to produce ergonomic and visually striking chair components. Using high-pressure presses and precision molds, multiple layers of wood veneers are bonded together with adhesive. These veneers are then pressed into the desired shape, creating smooth and durable curves that form the seats and backs of chairs. The presses combined with advanced molds enable the creation of complex forms with minimal material waste. This process demands rigorous attention to detail to ensure that each layer bonds correctly without gaps, which could compromise structural integrity. The molded plywood is then left to cure, allowing the adhesive to set fully and solidify the shape. This results in a seamless, high-strength product with a distinct, smooth contour, qualities that make chairs both durable and aesthetically pleasing. precision machining and finishing. Once the plywood components are molded, they are transferred to Carlaman's machining center, equipped with 5-axis CNC machines and CNC lathes. These advanced tools allow the workshop to achieve precision cuts and angles that enhance the functionality and comfort of each chair. The 5-axis CNC technology enables intricate detailing and consistency across each piece, ensuring that every component fits perfectly together in the assembly phase. Through this stage, the workshop ensures that each chair component meets strict dimensional standards for optimal ergonomics and stability. After machining, the plywood pieces are sanded to a smooth finish. This finishing process is conducted meticulously to remove any rough spots, ensuring a flawless surface ready for the next stage. Sanding and finishing teams focus on quality and consistency, paying close attention to ensure that every surface feels smooth to the touch and visually aligns with the overall design. Carlaman, a pioneer in creating high-quality shaped plywood, produces various components for seating furniture, including chair seats, backs, sofa arms, and monoblock chairs. The facility's production process reflects the company's commitment to durability, comfort, and aesthetic appeal, supported by its state-of-the-art technology and meticulous craftsmanship. Assembly and upholstery. Once the individual parts are complete, the assembly stage begins. Skilled craftsmen assemble the chair components, including seats, backs, and legs. During this process, each part is carefully fitted together to ensure stability and alignment. The workshop's attention to detail ensures that each chair is sturdy, with all components fitting together seamlessly. For upholstered chairs, the upholstery workshops handle the addition of fabric or leather coverings. The upholstery process is done with precision, ensuring that the materials are tightly and evenly applied to avoid wrinkles or loose areas. This adds another layer of comfort and aesthetic appeal to the chairs, enhancing their appeal in both residential and commercial spaces. Quality control and testing. Quality control is a critical part of the workshop's chair manufacturing process. The company applies 7 layers of Carlaman quality standard encompassing wood quality, craftsmanship, technology production standards, attention to detail, quality control, and delivery time. Each chair undergoes rigorous inspections at various stages of production, from raw material selection to final assembly. Painting and finishing touches. For certain chair models, the final step involves painting or applying finishes to protect the wood and enhance its appearance. Carlaman uses eco-friendly paints and finishes that enhance the natural beauty of the wood without masking its texture. Paint booths are used for even and controlled application, resulting in a smooth, durable finish. Additionally, finishing team meticulously applies protective coatings to increase the chair's longevity, ensuring resistance to moisture, scratches, and wear. After passing final quality inspections, the chairs are carefully packaged to prevent any damage during transportation. Packaging process ensures that each chair arrives in pristine condition.
This short film covers the building of the Grayhound at Southdown near Millbrook, Cornwall. The Grayhound building document is a part of Traditional Maritime Skills Project. The Traditional Maritime Skills Project embarks on a noble mission to preserve and celebrate the unique skills inherent in wooden boat building. At its core is the construction of the Grayhound, a 63-foot scale replica of the 1776 three-masted lugger, led by the experienced boat builder Chris Reese and a dedicated team of local shipwrights. The project is not merely about building a vessel. It is a concerted effort to safeguard and pass on the traditional maritime skills that are at risk of extinction. The short film documenting the construction of the Grayhound at Southdown near Millbrook, Cornwall, serves as a visual testament to the craftsmanship and dedication involved in this endeavor. However, the project extends beyond the construction site, addressing significant challenges faced by the maritime sector. The first challenge highlighted is the potential extinction of traditional ship and boat building skills. In an era dominated by technological advancements, these age-old skills face the threat of fading into obscurity. The second challenge is the difficulty in recruiting highly skilled workers adept in specific traditional boat building techniques. The situation is starkly illustrated by the example from the Netherlands, where only 5 individuals possess the skills to build or maintain traditional ships, and these skills are poorly documented and transferred orally. In response to these challenges, the Traditional Maritime Skills Project outlines 4 key solutions. First and foremost is the imperative to collect and record traditional boat building skills. This not only preserves the knowledge but also creates a foundation for passing it on to future generations. The second solution involves promoting these skills in both traditional and modern ship and boat building, bridging the gap between heritage and contemporary practices. The third solution aims to increase the number of individuals pursuing education and careers in wooden boat building, thereby replenishing the pool of skilled artisans. Lastly, the project envisions developing a training program on traditional boat and shipbuilding skills that can be customized to meet the evolving needs of the industry. The tangible outcomes of the Traditional Maritime Skills Project are designed to be practical tools for various stakeholders. A comprehensive training program is being developed, intending to nurture multi-skilled boat building professionals. Promotional materials, including fact sheets, displays, posters, and presentations, will be made available for educational organizations. An online virtual learning environment will be established, offering a repository of interactive resources. For businesses in the marine sector, the project promises a larger pool of highly skilled staff trained in traditional boat building. The customizable training program becomes a valuable resource for these businesses to tailor education to their specific needs. Furthermore, the project aims to elevate the profile of traditional boat building, generating increased interest in the field. Education organizations and individuals aspiring for careers in the marine sector stand to gain significantly from the Traditional Maritime Skills Project. A comprehensive training program opens avenues for those seeking a marine sector career, providing access to extensive learning resources. The project also envisions defining clear career paths in traditional wooden boat building, accompanied by high-quality marketing materials for schools and colleges to guide students toward further learning. In the low-lying expanses of the Netherlands, where water is as much a part of the cultural identity as windmills and tulips, traditional boat building has deep roots. Holland's rich maritime history is a testament to the craftsmanship and resilience of its people, who have navigated the intricate network of canals, rivers, and seas for centuries. This article delves into the art of traditional boat building in Holland, exploring the techniques, materials, and cultural significance that have shaped this enduring craft. Historical perspective. To truly appreciate the significance of traditional boat building in Holland, one must understand the historical context in which these vessels emerged. The Dutch, renowned for their seafaring prowess, have a long-standing relationship with water. With approximately 26% of the country situated below sea level, the need for efficient and reliable modes of water transport was paramount. The earliest evidence of boat building in the region dates back to the Middle Ages, with wooden vessels being the primary means of transportation. As trade routes expanded, the Dutch became master shipbuilders, and their boats evolved to suit the demands of the sea. These vessels played a crucial role in the country's economic development, facilitating trade and connecting communities. Traditional techniques. The traditional boat-building techniques in Holland have been passed down through generations, preserving a unique blend of craftsmanship and practical knowledge. Wooden boat construction remains a revered practice, with skilled artisans employing methods that have stood the test of time. One of the distinctive techniques used in traditional Dutch boat building is known as clinker construction. In this method, wooden planks overlap, creating a watertight seal. Oak, a durable and water-resistant wood, is often the material of choice for the frames and planks. The planks are fastened together using a combination of nails and wooden pegs, ensuring the structural integrity of the vessel. Another noteworthy aspect is the use of tar and pitch to seal the boats. This age-old practice enhances the wood's resistance to water, making the vessels more durable and seaworthy. The meticulous application of these materials is a skill honed by craftsmen who understand the nuances of boat building. The role of windmills. In the realm of traditional boat building in Holland, windmills play a crucial role. Beyond their iconic presence in the landscape, windmills were historically used to saw timber for boat construction. The power generated by windmills facilitated the precise cutting of planks, contributing to the efficiency and accuracy of the building process. Numbers in traditional boat building. Number of windmills. At its peak, there were over 10,000 windmills across the Netherlands. While the number has significantly decreased, windmills remain an integral part of the Dutch cultural landscape, with around 1,200 still standing today. Boat types. The diversity of traditional boats in Holland is reflected in the various types crafted over the centuries. From the iconic flat-bottomed barges known as punts, to the elegant zeeschouwen, designed for open waters, the craftsmanship has adapted to the specific needs of different regions and purposes. Workshops and shipyards. While many traditional boat builders operate independently, there are numerous workshops and shipyards dedicated to preserving and advancing the craft. These establishments serve as hubs where knowledge is exchanged and apprenticeships are formed to ensure the continuity of the tradition. Apprenticeships. The apprenticeship system is integral to traditional boat building in Holland. Young individuals interested in mastering the art learn from experienced craftsmen, inheriting not only the technical skills but also the cultural and historical significance embedded in each boat. Cultural significance. Traditional boat building in Holland extends beyond the functional aspect of constructing vessels. It embodies a cultural identity deeply rooted in the relationship between the Dutch and their maritime surroundings. These boats are not merely objects. They are vessels of heritage, carrying the stories of generations navigating the waterways that crisscross the landscape. The tradition of boat building also finds expression in festivals and events, where beautifully crafted vessels take center stage. The annual Cog Wooden Boat Festival, for instance, showcases the artistry of boat builders and celebrates the rich maritime history of the region. Such events not only draw attention to the craftsmanship but also foster a sense of community and pride in preserving this cultural heritage. Preservation efforts. In the face of modernization and changing technologies, there is a concerted effort in the Netherlands to preserve the art of traditional boat building. Museums dedicated to maritime history, such as the Zuiderzee Museum in Enkhuizen, house collections of historic boats, tools, and artifacts, providing a tangible link to the past. Government initiatives and grants support the restoration of historic vessels, ensuring that these floating monuments remain a living testament to Holland's maritime legacy. Additionally, educational programs and workshops aim to pass on the skills of traditional boat building to future generations, safeguarding a heritage that is both tangible and intangible. Grayhound is not just a boat. It is a testament to craftsmanship, tradition, and a daring vision to revive a piece of maritime history. The story of Grayhound begins in 2010 when Freya and Marcus Pomeroy Roden embarked on an ambitious project: build an English version of a three-masted lugger, a vessel design that had been dormant for 2 centuries. What makes Grayhound unique is not just its historical inspiration but the commitment to traditional boat-building techniques that went into its creation. Chris Reese, a well-respected boat builder, played a pivotal role in the project. Armed with plans for the 1776 revenue lugger Grayhound, he not only brought historical accuracy to the table but also took on the responsibility of designing and overseeing the construction. The journey began with Marcus felling oak trees from his mother's fields in Cornwall, setting the stage for a project that would marry modern technology with age-old methods. Fairley Restorations entered the scene, feeding Chris Reese plans into their computer to produce structural assessments, stability information, and framing patterns. In April 2011, tons of wood arrived at Chris Reese Yard in Millbrook, and by August, the boat was laid out in piles, resembling a colossal jigsaw puzzle. Shed 1 at Voyager Boatyard in Millbrook became the workshop where 6 shipwrights, including Marcus and a village apprentice, meticulously assembled the pieces of Grayhound. The keel-laying party marked a significant milestone, with people gathering to celebrate the birth of Grayhound. From this point forward, the construction progressed steadily. Planking, a critical phase, commenced in September 2011 and concluded in February 2012. The use of tree nails, wooden pegs, to fasten the planks was a nod to maritime traditions. Although this method had fallen out of fashion, its longevity was unmatched, with a life expectancy of 80 to 100 years compared to the 25 years of metal fastenings. Finally, in August 2012, Grayhound took to the water for the first time. A three-masted, wooden tall ship lugger, she sailed proudly as a 5/6 scale replica of the 1776 Customs lugger. The launch marked the beginning of a new chapter for Grayhound, as she ventured across the Atlantic, accumulating sea miles with cargo crossings. Grayhound is not just a vessel, it's a living piece of history. Residing primarily in Douarnenez, France, under new ownership, Grayhound maintains its love for exploration and the open sea. True to its 18th century ancestors, the ship boasts a rigging that mirrors that of 1776, offering guests an authentic and exhilarating sailing experience. Below decks, the traditional fit-out continues, marrying timber with considered spaces and a few modern conveniences. The communal saloon area accommodates 5 guests around an impressive oak table, while the shared fore-cabin provides an additional 5 berths, each with its privacy curtain. Sustainability is a guiding principle, with an eco-toilet on board and a shower for emergencies, while guest showers are primarily taken ashore. Life on board Grayhound is predominantly vegetarian, with exceptions made for sustainably caught meat and fish during sailing ventures. Sustainability is not just a buzzword for Grayhound, it's a way of life. The owners and crew are passionate advocates of sustainable sailing, emphasizing the reduction of engine time to minimize carbon emissions and pollution. By harnessing the power of the wind, Grayhound encourages a slower pace, allowing guests to savor the journey and destinations without the rush. The rhythmic movement of the boat and the sound of the wind create a serene connection with nature. The deck plan of Grayhound reveals a vessel designed for both practicality and aesthetics. With accommodation for 8 guests and a crew of 5, it strikes a balance between intimacy and functionality. The 19.57-meter length overall, 2.8-meter draft, and 21 feet 3 inches, 6.5 meters beam contribute to its seaworthiness and stability. The lugger rig with 9 sails covering a sail area of 470 square meters ensures that Grayhound is not just a relic but a capable and efficient sailing vessel.
Glover Furniture is the largest wood furniture factory in Chile, known for producing high-quality wood furniture at competitive prices for both domestic and international markets. This state-of-the-art facility employs advanced technology and efficient processes to turn raw timber into premium furniture. Here's an in-depth look into the production process at Glover Furniture. Raw material collection and initial processing. The production journey begins at a dedicated collection yard where raw wood is stored. The raw logs undergo an initial phase to remove bark through a debarker. This step is crucial for ensuring a smooth and clean surface, which allows for accurate sawing and minimizes potential damage to subsequent machinery. Sawmill operations. Next, the debarked logs are transported to the sawmill. Here, the wood is sawn into various dimensions, depending on the requirements of different furniture pieces. This process generates several byproducts, such as wood chips and sawdust, which are either repurposed within the factory or sold for other applications. Sawmill operations are carefully managed, with tool maintenance scheduled every 4 hours in the tool maintenance section, ensuring optimal performance and precision. Environmental responsibility and safety measures. Throughout the production process, Glover Furniture places a strong emphasis on sustainability and workplace safety. The factory operates a thermal unit that utilizes waste materials to reduce environmental impact, showcasing the company's commitment to eco-friendly practices. Additionally, the company provides extensive safety training and enforces strict safety protocols, creating a secure working environment for all employees. Drying and moisture control. Once cut, the wood enters the drying phase, beginning with storage in a controlled environment to stabilize before going to the drying boiler. The drying process is meticulously monitored, with regular moisture measurement to ensure that the wood reaches the ideal moisture content. This step is essential because moisture affects wood stability and helps prevent warping, ensuring that the finished furniture will be durable and of high quality. Planing and sizing. After drying, the wood moves to the planing and chopping stage, where it undergoes planing and sizing. This phase prepares the wood by smoothing its surfaces and trimming it to precise dimensions, setting a consistent foundation for further processing. Molding and calibration. With the wood ready, the molding machine is employed for molding and shaping. The calibration process ensures that each piece meets exact specifications. This stage includes quality control, with checks performed on each piece to guarantee uniformity and adherence to design standards. Embracing technology for the future. The company continually invests in cutting-edge technology to streamline processes and improve product quality. By incorporating the latest automation and machinery, such as the CNC machine and high-precision sanders, the company stays competitive in the global furniture market. Machining and fine details. In the machining section, precision machines such as the CNC router are used to carve intricate patterns and details into the wood. This machine allows for flexibility in design, creating everything from classic to modern styles with high precision. Sanding and surface preparation. After machining, the wood surfaces are smoothed using a sander. This machine plays a vital role in preparing the furniture pieces for finishing by creating a smooth and consistent surface, essential for an even application of paints, stains, and lacquers. The facility also produces briquettes from leftover sanding materials, a byproduct that can be used as an eco-friendly fuel source. Assembly. With each component prepared and sanded, the next step is assembly. Skilled craftsmen carefully assemble the furniture pieces according to the design specifications. This step requires attention to detail and a good understanding of furniture construction, as it is crucial for creating sturdy, functional, and aesthetically pleasing pieces. At this stage, any additional fittings, joints, or reinforcing elements are integrated to ensure durability. Finishing, painting, and lacquering. Once assembled, the furniture is moved to the painting and lacquering sections for finishing. Here, each piece receives a coat of paint or lacquer, enhancing its appearance and providing a protective layer. The factory uses advanced spraying systems to apply these finishes evenly, creating a polished look and protecting the wood from moisture, UV exposure, and daily wear. final quality check and dispatch. Before leaving the factory, every piece undergoes a final quality control check to ensure it meets Glover's high standards. This inspection covers everything from build quality and stability to finishing consistency and aesthetics. Once approved, the furniture is packed and stored for dispatch. Here, it is prepared for distribution to showrooms and customers across Chile and abroad, ready to meet the needs of homes and businesses worldwide.
Basargin boats are renowned for their exceptional craftsmanship and attention to detail. The construction of a Basargin boat begins with the creation of a plug. The plug serves as the template for the boat's hull shape and is made of wood. Once the plug frame is complete, the next step is to plank the curvatures. Thin wooden planks are carefully affixed to the frame, following the contours of the design. The planking process requires precision to ensure a smooth and seamless hull surface. After the planking is complete, the boat undergoes an extensive sanding process. This step involves smoothing out the surface, eliminating any irregularities or imperfections in the wood. The goal is to achieve a flawless and even finish. To further refine the surface, the entire hull is filled, ensuring that any remaining gaps or indentations are properly addressed. Once the filling is complete, another round of sanding commences. Skilled craftsmen meticulously sand the surface, ensuring that all imperfections and high spots are meticulously smoothed down. With the hull surface perfected, the boat enters the next phase, priming. A layer of primer is sprayed onto the surface, providing a protective base and enhancing the adhesion of subsequent coatings. After the primer has dried, the hull is sanded again to create a smooth and receptive surface. To protect the boat's surface and enhance its longevity, a waxing process follows. Wax is carefully applied to the primed hull, providing an additional layer of protection against the elements and giving the boat a polished appearance. After that, a gel coat is applied to the surface, which serves as a protective layer. It is a specially formulated resin that contains pigments and additives to enhance its durability. Skilled craftsmen meticulously spray the gel coat onto the surface of the plug, ensuring even coverage and a smooth finish. Layers of fiberglass sheets are carefully laid onto the prepared surface, following the contours of the plug. The fiberglass sheets are impregnated with resin and positioned to provide optimal strength and structural integrity. Expert craftsmen work diligently to eliminate any air bubbles and ensure a solid bond between the fiberglass and the gel coat. The fiberglass work is a critical stage in boat construction as it provides the boat with its structural strength, rigidity, and resilience to withstand the forces of the water. The precise application of the fiberglass layers and resin is essential to create a durable and reliable hull. Then the boat progresses to the subsequent steps in the construction process, such as applying the fell layer and the core material. Once the hull is built and cured, it is carefully pulled out of the mold. This process is done with precision and care to avoid any damage to the newly formed hull. The result is a beautifully crafted Basargin boat, ready for further finishing touches and customization.
The wooden door manufacturing industry has a long history, marked by evolving techniques and technologies to meet the growing demand for aesthetically pleasing, durable, and functional doors. Globally, the industry is supported by increased construction activities, remodeling projects, and rising preferences for eco-friendly and sustainable products. From raw material procurement to finishing touches, the sector has made remarkable strides in automation, quality control, and customization options. Industry overview. Wooden doors constitute a significant portion of the door market, which had an estimated value of approximately $110 billion in 2023, with wooden doors contributing around 30 to 40% of this total. The wooden door segment is expected to grow at a compound annual growth rate, CAGR, of around 5 to 6% over the next 5 years. Key regions driving this growth include North America, Europe, and Asia-Pacific, with emerging markets in South America and the Middle East showing increasing demand due to urbanization and construction activities. Types of wooden doors and their demand. The wooden door market is diverse, offering various types based on function, design, and material. The main categories include solid wood doors, panel doors, flush doors, barn doors, and French doors. Solid wood doors, known for their durability and rich appearance, dominate the market but are often more costly. They account for about 30% of the market share in residential applications due to their appeal in homes, hotels, and upscale construction. Panel doors, particularly raised panel designs, are popular for interior applications, providing both aesthetic and functional benefits. Flush doors made from wood veneer or plywood are lightweight and commonly used in commercial settings due to their cost-effectiveness. Each type of door meets different customer needs and price points, with a steady growth in demand for all categories. Materials used in wooden door manufacturing. The industry uses several types of wood, each with unique characteristics that cater to different segments of the market. Oak, pine, cherry, walnut, mahogany, and maple are popular hardwoods for solid doors, with oak accounting for roughly 25% of wooden doors globally due to its strength and aesthetic appeal. Softer woods like pine, accounting for around 15% of the market, are often used in cost-effective doors and are ideal for painting. The sustainability trend is impacting the material selection in the industry, with manufacturers increasingly turning to certified sustainable sources. The Forest Stewardship Council, FSC, and other certifications are becoming standard, as around 60% of manufacturers in North America and Europe now prioritize FSC-certified wood. Additionally, engineered wood, such as medium-density fiberboard, MDF, and high-density fiberboard, HDF, is used extensively in flush and panel doors to reduce costs and improve stability. The production process for wooden doors consists of several steps, including material selection, cutting, shaping, joining, finishing, and quality control. Material selection and preparation. The first step involves selecting the wood type based on the door style and budget. Kiln-dried wood is often used to prevent warping, a common issue in wooden doors. Moisture content is kept at around 6 to 8% for stability, particularly in hardwood. Cutting and shaping. The wood is cut to size and shaped according to the door design. This process includes routing and carving panels, creating grooves, and setting recesses for locks and hinges. Advanced computer numerical control (CNC) machines, now used by over 70% of high-capacity manufacturers, ensure precision in cutting and shaping. Joining. The parts of the door are assembled using joints, typically mortise and tenon, dowel, or finger joints. In higher quality doors, mortise and tenon joints are used for their durability, while dowel joints are popular in lower cost doors. Adhesives with formaldehyde-free compositions are now preferred, contributing to about 40% of adhesive choices in the market. Finishing. Finishing involves sanding, staining, and coating to enhance the door's appearance and protect it from environmental factors. Automated finishing lines are gaining popularity, especially for large manufacturers, as they improve consistency and reduce labor costs by up to 30%. Water-based stains and low VOC, volatile organic compounds finishes, are also becoming industry standards due to environmental regulations and consumer preferences. Quality control. Quality control ensures the doors meet specifications in terms of size, appearance, and functionality. Testing includes moisture resistance, impact resistance, and thermal expansion, depending on the door's intended use. Leading companies allocate around 5 to 7% of their production cost to quality control, including automated inspection systems that reduce defect rates by about 10 to 15%. Market trends and innovations. The industry is seeing a push towards sustainable and energy-efficient products. Doors with low thermal transmittance (U) values are in demand, particularly in regions with energy efficiency regulations. Wooden doors with insulating cores or energy-efficient glass panels are becoming popular for exterior applications, with an annual growth rate of about 8% for such products. Customization is another prominent trend. Consumers are increasingly looking for doors that reflect personal style and fit unique dimensions or features, such as inlays or bespoke carvings. Smart technology integration is on the rise, with options for fingerprint recognition, electronic locking mechanisms, and soundproofing materials. Smart doors represent a small but growing segment, with an expected CAGR of 10% through 2030.